So in last class we have discussed the estimation of linkage in backcross data. In this class we will discuss another cases, say estimation of linkage in F2 generation. So for this, let us consider a F2 generation in which first generation we will get capital A, small a, capital B, small b is crossed with capital A means selfing is there. Then suppose these are females and these are the males. When this crossing take place, then the parents will produce four gametes, and these gametes from, if you take this side and this side, we will get these four gametes of each parent. And if I considered this as female parent and this as male parent, and their recombinant fractions is represented by say PM or PF. If PM is the recombinant fraction of male and PF is the recombinant fraction of female, then the four phenotypic classes for male gametes and female gametes are given in this table. So these are the types of gamete: capital A, capital A, capital A, capital B, capital A, small a, capital B, and small a, small b. So in case of male gametes, if I consider PM as the recombinant fraction of male, then you will get this. And for recombinant type, you will get this. And for this class, this is the proportion. Similarly, for female, it is 1 minus PF by 2, PF by 2, PF by 2, and for small b, it is 1 minus PF by 2. Now, as I have already told, suppose PM is nothing but it is the recombination fraction of male parents, and PF is the recombination fraction of female parents. Here also our aim is to calculate recombination fraction, this PF and PM. So here our aim is to calculate the recombination fraction PM and PF. So for this, let us consider a case of coupling phase. So now consider, in case of coupling phase, we have to combine two types of gametic distribution at in all possible combination. So the double recessive progeny, which is given by AABB, is then expected to occur how many times? The AA is 1 minus PM, it is 1 minus PF, and by 2 by 2. So when I multiply it, so it becomes 1 minus PM into 1 minus PF divided by 4. So for double recessive progeny, small b is occur in so much cases. And the total probability of this recessive progeny is 1 by 4 respective of linkage in F2 family with dominance. Now, what is the probability of capital A, small b, sorry, and small a, capital B in phenotypic classes? So, the probability of capital A B or small a, capital B phenotypic classes is given by, I just subtract, since it is 1 by 4, so minus this thing. So, it will be equal to 1 by 4 minus 1 minus Pm into 1 minus Pf divided by 4. So on simplification, if I take 1 by 4 common, so this becomes 1 minus Pm into 1 minus Pf. And the probability of capital A, capital B phenotypic class is given as, say, 1 minus twice. This is for recombinant type and this is for recessive part. So this is the probability of AB phenotype class. And if I simplify this, this becomes 4. If I take 4 as LCM, then this 1 is multiplied with 4 minus 2 times this side minus this thing. And on simplification, when 4 minus 2, it becomes 2 plus 2 times 1 minus Pm into Pf by 4. So the phenotypic class expected frequency distribution we will get is this. We have four classes: capital A, capital B, capital A, small a, capital B, and AB. And their expected frequency are 1 by 4, 2 plus theta. I will explain what is theta. 1 minus theta, 1 by 4, 1 minus theta, and theta by 4. From where this theta comes? Where theta is nothing but it is the product of 1 minus Pm into 1 minus Pf. In case of say coupling case, and if your Pm and Pf is equal to say P, then it becomes theta becomes 1 minus P whole square. Similarly, in case of repulsion phase, what happens? The again we will consider four classes: AB, capital A, small a, capital B, small b, and their expected frequency are as usual these. Here, theta is taken as the product of Pm and Pf by 4. And again, if Pm is equal to Pf, say it is equal to P, then theta will be equal to P square. So, from above discussion, we came to know that in F2 data can only estimate for the parameter theta and note the separate parameter Pm and Pf, which means recombinant fractions. We cannot estimate the recombinant fraction separately. We can estimate theta. At the most, we can estimate the product of two recombination fractions. That is Pm into Pf or product of 1 minus this thing. Clear? Now, if your recombinant fraction of male is equal to recombinant fraction of female, and which is further equal to say P, then what happens? Then in repulsive phase, theta will be equal to P square. When theta is equal to P square, then you can estimate the P by just taking the positive square root of theta. Then in repulsive phase, theta will be equal to P square because Pm into Pf is your theta. Or when Pm is equal to Pf is equal to say P, then theta will becomes P square. And P can be estimated by under root theta. In case of coupling phase, we will take P cap as 1 minus under root theta. But when linkage in one of the parent is in the coupling phase and in the other in the repulsive phase, then what happens? if linkage in one parent is in coupling phase and other in repulsion phase, then what happens? Then how will you estimate the theta? Then we have theta is equal to 1 minus Pm, and this is in repulsive phase, or 1 minus Pf, this is in repulsive phase. And again, if Pm is equal to Pf is equal to say P, then we can estimate P as 1 minus under root 1 minus 4 theta by 2. So this is the procedure. You can estimate theta and P. Now let us continue with the discussion. We have already discussed the maximum likelihood method to estimate the linkage, that is the estimation of P, in previous lecture in case of back cross. Now we will discuss it for F2 generation. So for this we will prepare a table in which we have phenotypic class, all four phenotypic class, their expected frequency, their observed frequency, and then we will estimate. So these are my four phenotypic classes. Their expected frequency are 1 by 4, 2 plus theta, 1 by 4, 1 minus theta, 1 by 4, 1 minus theta, and it is theta by 4. Their observed frequency for this class is A1, capital A small b is A2, small a capital B is A3, and a small b is A4. And our theta in coupling phase is nothing but it is the product of 1 minus Pm into 1 minus Pf. In repulsive phase, theta is the product of Pm and Pf. Then the method of maximum likelihood, the likelihood of obtaining observer data in four phenotypic class can be derived from, as I have already said, through multinomial distribution. And log and likelihood function is represented like this. This is n factorial, means if sum is n, so this is n factorial divided by a1 factorial, a2 factorial, a3 factorial, a4 factorial. Now your m, here expected frequency is 2 plus theta by 4 raised to power the observed frequency. 1 minus theta by 4 raised to power observed frequency. 1 minus theta by 4 raised to power observed frequency, and so on. So in order to simplify it, we will take the natural log of this L. So log L can be written as C. If I consider it as a C, I can consider because n is constant and these are all again constant. So it is C plus A1 log 2 plus theta by 4 plus A2 times log 1 minus theta by 4 plus A3 times log 1 minus theta by 4 plus A4 log theta by 4. Now we will estimate the value of theta in usual way just by taking the derivative of this log L and equating it to 0, taking the second derivative and it should be negative. So let us do it. In order to maximize the log L, we get the estimating equation. Say curly log L upon curly theta is equal to 0 and curly square log L upon curly theta square is equal to negative. So first of all, we will take the derivative of log L with respect to theta. So log L with respect to theta is A1 divided by, since this is in log, so as I have already tell, ax minus b and log of this, or you can say log of ax minus b and its derivative. So it is nothing but it is 1 upon ax minus b into derivative of ax minus b. So a times. So this is 1 by 4 comes here. Similarly, a2 1 upon 1 minus theta by 4 into 1 by 4. Then 1 by 4 and so on and so forth. On simplifying it, this 4 cancelled out with this 4 cancelled out with this 4, this with this with this. So what we left? We left okay. So we left a1 divided by this 2 plus theta because this 4 is cancelled out, minus. Why it is minus? I have forgotten to write something. This is minus 1 by 4 and this is again minus 1 by 4. So this is minus, this 4 cancelled with this, a2 by 1 minus theta. And here this cancelled, so I will get minus a3 by 1 minus theta plus a4 by theta, and equate this equation equal to 0. What I will get? a1 upon 2 plus theta minus a2 upon 1 minus theta minus a3 upon 1 minus theta plus a4 upon theta is equal to 0. This will give me a equation. When I take the LCM of this, I'll get 2 plus theta into 1 minus theta into theta. So a1 is multiplied with theta into 1 minus theta. Similarly, a2 is multiplied 2 plus theta into theta. a3 is also multiplied with 2 plus theta into theta. And a4 is multiplied with 2 plus theta into 1 minus theta. So my equation is a1, it is multiplied with 1 minus theta into theta, minus a2 theta into 2 plus theta, minus theta into 2 plus theta a3, 2 plus theta into 1 minus theta a4 is equal to 0. Then I just rearrange these thetas and a1 and a2 like this. So a1 1 minus theta. Now from these two, minus theta into 2 plus theta. It is common in these two terms. So I take theta into 2 plus theta common. So what I left? a2 plus a3. So a2 plus a3 into this and a4 as such. Now I just multiply this theta with all these terms. So I will get a1 into theta minus theta square minus a2 plus a3, 2 theta plus theta square, a4 2 minus 2 theta plus theta minus theta square is equal to 0. Now distribute all these constant term with theta. So I will get a1 theta minus a1 theta square minus twice theta a2 minus a3 theta square. When I multiply this 2 theta with twice of 2 a2 theta, twice of theta square, then a3 minus twice of a3 theta minus a3 theta square then 2a4, these two are multiplied, minus theta a4. Now from this you will say minus theta. From these two we only minus theta is remained. So minus theta a4 and minus theta square is multiplied by a4. It is minus theta square a4 is equal to 0. So I obtained this in a theta square term. So this can be written like that. If I combine this term and this term and take theta square common. So what I get? This is minus a1, this is minus a2 from this, minus a3 and minus a4. Then I combine all the terms of theta and take theta common. So what I will get? Here theta, so it is a1 minus twice this this theta minus twice a2 minus twice a3 minus a4 plus we have another term 2a4. Now if you look this equation, this is quadratic in theta. This is the coefficient of theta square, this is the coefficient of theta, and this is your constant term. So you can write like that. If I take minus common from this equation, so I will get a1 plus a2 plus a3 plus a4, which is nothing but it is my n. And this term as such plus 2 times a4 is equal to 0. Now this is a quadratic equation. Now you can estimate theta from this equation. So from this equation, we can estimate the value of theta. This value of theta will be the estimate of theta. We know that variance of theta cap, now we have estimated theta cap through this equation. Now we can find out the variance of theta cap as usual by 1 upon expected value of curly square log of L upon curly theta square taking negative sign. So this is the formula, and again we know that our log L is nothing but it is this one. So taking curly log L upon curly theta, this taking second derivative with respect to theta, I will get minus a 1 2 plus theta, because and this is minus a2 1 minus theta square minus 1 minus theta square a3 and theta square by a4. So and if I take minus common from all these terms, then I will get variance of P, which is given by minus 1 upon this thing, expected value of this thing. So if I take minus common, then this minus cancelled out with all these minus. And I will get 1 upon expected value of A1. A1 is nothing but 2 plus theta by 4 into total number of individuals. A2, this is the expected value. For A3, this is the expected value, and for A4, this is the expected value. You just substitute these value in this equation and simplify it. What we will get? So you will get 1 upon now if I this n this 4 is there, 2 plus theta, I think something is wrong here. Let me check. 2 plus theta, sorry, 2 plus theta upon 4 n when it is divided with this term. So it becomes, I think this should be cube, and rest of things are okay. Then on simplifying it, if I simplify it, if I take the product of all these four, this is goes in numerator, and in denominator you will get n times theta into 1 minus theta plus 2 into, this is simplification, everybody can do it. And finally, it is like this. So if you simplify it, this minus theta square cancelled with 2 theta square, plus theta minus 2 theta, and this cancelled out. So we have left with 2 plus 4 theta in the denominator. So on in numerator it is 4, 2 plus theta, 1 minus theta into theta, and we will get n times 2 plus 4 theta. Right? So if I take 2 common from this, so this is 4, 2 plus theta, 1 minus theta, theta, 2n, 1 plus 2 theta. Now this cancelled out with 2. So ultimately, variance of theta cap can be 2 times 2 plus theta, 1 minus theta into theta divided by n times 1 plus 2 theta. Now, if we consider, say, the recombinant fraction of male is equal to recombinant fraction of female is equal to, say, P. If recombinant fraction in male and female are same, then what happens? Then we know that P cap can be estimated by 1 minus theta cap in coupling phase, and in repulsion phase P cap is nothing but it is under root theta as we derived earlier. So in repulsion phase it is under root theta. So now we will use a result. We will use a result if for a given y is equal to fx is any relation, then variance of y can be obtained is equal to curly fx upon curly x whole square into variance of x. Now from this you can find out variance of x as you just substitute variance of y, divide it by this thing. So variance of y upon this will give you the variance of x. Or you can say variance of y upon curly x whole square. Because curly fx is curly y. So you can arrange like this. But how we can use this result in our case? In our case, what is your y? Y is your nothing but it is your theta. And x is your recombinant fraction p. So in our case, y will be equal to theta and x will be equal to p, and theta is nothing but 1 minus p whole square under coupling phase, and theta will be equal to p square in repulsive phase. So theta 1 minus p square under coupling phase. So your variance of p can be obtained by using this relation. Y is theta, so variance of theta upon curly theta curly p whole square. So variance of theta curly theta or curly p is nothing but 2 minus 2 into 1 minus p whole square, and variance of theta will be equal to 4 times 1 minus p whole square. Now 1 minus p square is nothing but it is your theta. So variance of theta divided by 4 theta. So we can find out variance of P as variance of theta, which is this one, divided by 4 theta. So in this way, you can estimate the variance of F2 generation. Now let us talk about what consequences or what important thing we have observed. So you may write a note when phase of linkage in coupling in both sexes and repulsion in both sexes, the result will be same as we get in equation 1, but theta will be different. And also the result will be same when it is in coupling in one sex and repulsion in another sex. Under the condition that recombinant fraction of male and female are equal and is equal to P. So coupling phase theta is equal to P square in repulsion phase, and theta will be equal to 1 minus P into P in case of one sex is in repulsion phase and other sex is in coupling phase, right? So you should note the range of P. What will be the range of this fraction? The range of P is 0 to 0.5. So it lies between 0 and 0.5. At P is equal to 0.5, no linkage. And P is equal to 0, there is a complete linkage. Now we will consider these repulsion. So we know that P cap is equal to 1 minus under root theta in coupling phase and P cap is under root theta in repulsion phase. Under the condition, then recombinant fraction in male and female are equal. So if PM and PF are not equal, unless one of PM or PF is not known, combinate fraction cannot be calculated. So these are the few points you should keep in mind when you calculating or when you estimating the linkage in coupling or repulsion phase. Now, in case of back cross, how will you estimate the linkage? When you have the recombinant fraction of male and female are different, and then we consider a case when they are equal, and then we will develop certain relationship. So in case of back cross, your chi-square linkage will be given by B1 minus B2 minus B3 plus B4 whole square divided by n dash. So let us consider this linear function. So let us consider this linear function. So x is equal to your B1 minus B2 minus B3 plus B4. Then if we want to find out the expected value of x, then you can find out the expected value of B1 minus expected value of B2 minus expected value of B3 plus expected value of B4. Now, what is the expected value of B1? It is nothing but it is 1 minus P by 4 minus B2 into, sorry, the total number of individual. It is P by 4 into n dash minus P by 4 into n dash plus 1 minus p by 4 into n dash. So expected value of x can be given like by this expression. If you simplify it, then if I take n dash common and 4 common, so n dash by 4 if I take common, what I will left? 1 minus p minus p minus p plus 1 minus p, right? So this you will get you will get if it is right, minus p minus p minus p minus p upon 4. So and n dash, how it is possible? It is 1 by 4 n dash. Let me simplify it. It is 1 plus 1 2 minus 4p upon 4 n dash. So it is n dash by 2 and minus np dash. So this is okay. So it is n dash minus 2. This is all right. So you will get this expression. Then n dash p, n dash p. Now from this expression, the n dash p is equal to n dash by 2, this is this one, minus b1 minus b2 minus b3 plus b4. And your p can be estimated just dividing this n dash by this, which is the estimator of p by chi-square method of estimation in case of back cross. So this is the second method, which is known as chi-square method of estimation in back cross, right? Now in case of F2, how you will estimate? In case of F2, we will consider all four phenotypic classes and their expected frequency as M1, M2, M3, M4. Observed frequency A1, A2, A3 and A4. Then the chi-square method based on linkage chi-square in F2 can be given as usual. This is A1 minus 3A2 minus 3A3 plus 9A4 divided by 9n. I have already explained it. So it is A1 minus 3A2 minus 3A3 plus 9A4 over 4n. Now if we consider this as a linear function, so let us consider x as the linear function. This, then find out its expected value. Of course, expected value of A1 in F2 is 2 plus theta by 4. This is 1 minus theta by 4, 1 minus theta by 4, and it is theta by 4. So if I simplify this, so 2 by 4 minus 3 by 4 minus 3 by 4 and n is there. So I club these things. Then theta by 4, and if I take common, then I will get this 1 plus 3 this plus 3 this plus 9 this. So my expected value of x is n plus 4 theta n. How? If I find out this is 3 and 3 6 minus 6 plus 2. So minus 4, 4 by 4, this is minus 1. So this is minus n. And in this case, it is 16 by 4. So this is 4n. So you will get, I think this is minus. And your expected value of x plus n upon 4 theta. Because if I take n this side and divide it by 4n, then it becomes theta. So theta cap can be estimated. This is the expected value of x. So theta cap can be estimated a1 minus 3 a2 minus 3 a3 plus 9 a4 plus this n divided by. And if I substitute the value of n here and simplify it, then theta cap can be written like that. Because n is a1 plus a2 plus a3 plus a4, and on simplification I'll get 2a1 minus 2a2 minus 2a3 plus 10a4 by 4n. And if I take 2 common from this expression, finally I will get theta cap is a1 minus a2 minus a3 plus 5 times a4 upon 2n. So which gives the estimate value of theta in F2. Then there are two more methods we can use. So in case of F2 population, the expected frequency in 4 phenotypic class are such that as theta, which is nothing but recombinant frequency, as theta increases, the frequency in first and fourth class, which are representing your parental genotype, increases, while the frequency in second and third class, which represent the recombinant genotypes, will decrease. So now define the linear function E minus M, where E is your A1 plus A4 parental type, sum of the parental type, and M is your recombinant type. So I will explaining in one more method which is known as emerson method of estimating linkage. So in this case, we will find a linear function E minus M, where E consists of the sum of parental type and M consists of sum of recombinant type. And then we will find out its expectation. The expectation of E minus M is given by expected value of E minus M. So expected value of E, the value of E is A1 plus A4 minus A2 minus A3. And if I substitute these expectation here, then what I will get? Expected value of A1 is as usual 2 plus theta by 4 into n. Expected value of A4, it is theta by 4 into n. A2, 1 minus theta by 4 into n. Expected value of E3, 1 minus theta by 4 into n. If I substitute all these values in this expression here, what I will get? Expected value of E minus M is 2 plus theta by 4 into n, theta by 4 into n minus this. And if I simplify it, we will get this expression, which gives us theta as expected value of Em upon n. And estimate of theta is nothing but E minus M upon n. And we can find out now the variance of theta cap. The variance of theta cap is nothing but it is 1 minus theta square upon n. And variance of P, we already calculated, it is variance of theta upon 4 theta. And variance of theta is 1 minus theta square upon n. I just substitute these value here. Then this variance is same in both coupling and repulsion phases. In coupling phase, theta will be calculated 1 minus p whole square, and in repulsion phases, theta is equal to p square. Only when the recombinant fraction of female and recombinant fraction of male are equal and it is equal to p. And if one parent shows coupling phase and other parent shows repulsion phase, then theta will be p times 1 minus p. And we obtained this variance as this thing. Then one more method I am going to tell you is product ratio method of estimating linkage. It is a very simple method. In this method, we find the product, which is the parental type product, and divide it with recombinant type product and define this product as Q. So we will find this product, and if I substitute the expected value A1, A4, so A1 is 2 plus theta by 4, and this is theta by 4, and divide it by its expectation, that is you can say 1 minus theta and so on and so forth. So you will get this expression. And if I cross multiply these two terms, q times 1 minus theta whole square is equal to 2 plus theta. Now if I simplify it, then it becomes a quadratic in theta, from which two root can be obtained, and positive root is taken as an estimate. Right? So you just simplify it, you will get this expression. And your theta will be 1 plus q minus 1 plus 3q upon q minus 1. You can find it out by your own. So variance of theta in maximum likelihood method and product ratio method are equal, and which is given by 2 theta, 2 plus theta, 1 minus theta, n times 1 plus 2 theta. There are two more methods which just I introduce you how to estimate the linkage. So another method is minimum chi-square method. In this method, we compute chi-square theta I minus expected value whole square divided by EI. Here we will minimize this chi-square with respect to theta. And from this, we can find the estimate of theta. I am just giving you the introduction. The detail you can find out in many books. There is one more method which is known as least square method. In least square method, which is most commonly used method to estimate linkage, or you can say what we do in least square, I just in least square method we will minimize observed minus expected whole square, then find the value of theta. But among all these five method we have discussed, the most commonly used method to estimate linkage is MLE. It gives an estimate with the smallest possible sampling variance in the theory of large sample. So this is all about linkage. We will discuss some more topics in subsequent classes. Thank you.